Hello and welcome along, Explorer. It's time for you and me to search through the solar system. My name's Dan. This is a brand new Fun Kids Science Midweekly. And it's a questions special. If you ever have anything sciencey floating around your brain like a loose meteor just drifting past Pluto, then send it over to me as a voice note on the free Fun Kids app. You can do it at funkidslive.com too. That way I can see it, you can star in the show, and I can do all the digging. First up, let's get one of those in. This is a question sent in by Arun.
Hello, Dan. My name is Arun, and I would like to know how fast do you need to go to burn up? Thank you.
Hey, Arun, how fast do you need to go to burn up? I reckon you mean by burning up when something enters Earth's atmosphere so fast that all the particles rushing past it bump into it. They make it get so hot it falls apart, you know? Like a meteor, like an asteroid travelling through our atmosphere. It kind of burns up. It glows, doesn't it? Well, that's burning up, and you need to be travelling above, really, 25,000 miles an hour to burn up. That's on average, but it depends how small or how big you are, how much there is to break up. 25,000 miles an hour, that's actually Earth escape speed. Anyone or anything travelling at that speed can escape Earth's gravity. That's how fast you need to move away, really. A plane goes at about 600 miles an hour. That's not nearly fast enough. Some big objects, like falling satellites and space debris, they can burn up a bit over 15,000 miles an hour. So yeah, different objects need different speeds before they might start to fall apart bit by bit. Others, travelling at 7 miles a second might completely vaporise. So there's a lot there, Arun. It depends how big you are, how small you are, what you're made of. But normally you need to be travelling at about 25,000 miles an hour to burn up, or even to escape our atmosphere, Arun. Thank you very much for the question. Here's one sent in as a message from Rory. Rory, hey Rory, you want to know what are white blood cells made of? White blood cells are about 1% of your blood, but they have a huge impact. They protect you against illness and disease. They are your immunity cells. They're pretty much always at war. They're made in the bone marrow, which is inside your bones, and they're stored in tissues all around your body, but they only last for a few days. You're always making new ones, and white blood cells is kind of the grouping. You've got a few different types of cell in there. You've got the neutrophil, which sounds like a mouthwash, doesn't it? But anyway, the neutrophil targets bacteria. The eosinophil gets parasites. The basophil helps inflammatory response, so helps your blood kind of get to work and help fix you. The lymphocute helps with antibodies. The monocyte moves around the body, just helping stuff out. So all of those different cells, they're kind of like troops on a battlefield that all know their jobs. They're made of cells, that's what they are, and cells are made of molecules, acids, carbs, and proteins. What makes white blood cells stand out is that they have a nucleus, so almost a brain in the middle that tells them what to do, which other cells don't really have. So Rory, I hope that's helped you out. That's what white blood cells are made of. This is from Luella, who is 8 years old, who wants to know why vampire bats drink blood. A couple of questions all about blood today. Well, Luella, they're the only blood-eating mammals in the world. Vampire bats drink blood because that's how they've evolved. We've spoken about this so much on the show. Animals, life evolves to make the most of what they can to survive. Other animals aren't drinking it, so it's allowed them to survive and thrive in the wild. Vampire bats have developed that they can feast on blood. Other creatures aren't doing it. Well, that's loads for me then. That's what they're thinking. How they do it is quite fascinating. They have special bacteria in their gut that helps them survive on it. They gallop along the ground on all fours. Then they leap onto a victim, slicing into their veins with razor-sharp teeth. They have special nerves in their face that helps them sense the heat in prey's veins, so they can be really efficient and get the most blood. They've also got an enzyme in their saliva, which stops the blood from clotting so they can keep drinking it. Blood is hard for the kidneys to turn into healthy stuff that animals need to live. So the gut bacteria helps them out with that. It's kind of a deal that they make because that gut bacteria has a warm place to stay, and in return, it helps the vampire bats survive. Luella, that's how vampire bats drink blood. Thank you for the question. Now, you've got just a couple more chances this year to come and explore the universe with me live on stage. We've got just 2 more shows for Fun Kids Science Weekly Live. If you're being really quick listening to this, we've got a show in Leeds on Saturday the 18th of October. We'll be at the Carriage Works Theatre with me, with you, with genius guests, with deadly beasts, with explosive experiments. Your chance to hold something from outer space too. We've got a live meteor right there. We'll do high fives, we'll do selfies. I can't wait to see you. That's happening on Saturday in Leeds. And then we've got one more show of the year. On Tuesday, the 21st of October, we'll be in Chelmsford with more amazing adventures around the universe. You've got just 2 more chances left this year to see Fun Kids Science Weekly live. I would love to see you there. So get a ticket, grab a grown-up, head over to funkidslive.com/tour to book your place on our exploration of the universe. More questions then. Here's one as a voice note from Ben.
Why does acid rain happen?
Well, Ben, acid rain happens when pollutants in the air react with water, oxygen, and other chemicals up there to make rain that is, drumroll, acidic, yes, often harmful. These pollutants can come from all sorts of places. Maybe power plants, the burning oil or coal, or perhaps car exhausts. So, for instance, when a concentration of sulfur is in the air, that can react to make sulfuric acid rain. Other chemicals and pollutants make other types of acid rain. And it causes damage for things across the world. And like all problems in science, like so many ways that humans affect the world, it's often in ways that we don't really think about. Like it leaches into the soil, it releases toxic metals which harm plants, which harm the animals that want to eat the plants, which maybe harms us. Also, it gets into lakes and streams, endangering fish. It can erode stone and metals, which damages buildings. It can damage leaves and harm trees, causing destruction to forests. So, Ben, that's how acid rain happens. That's why it happens. And it just causes damage that we don't think about, that can really affect not just us, but the whole ecosystem around us. Thank you for the question. Here's a question from Jamie, who wants to know, how do you know when one galaxy ends and another begins? Well, a galaxy is a huge collection of gas, dust, stars, and solar systems that are all held together by gravity. What links a galaxy is it's normally held together by one source of gravity. Our Milky Way galaxy is held together by a supermassive black hole in the middle. That's quite common across galaxies. But our galaxy and a close one, Andromeda, they are orbiting each other. So they're gravitationally bound. They're kind of in sync, all spinning around each other. So back to your question. When one galaxy ends, there will be a huge amount of space and then more stars, which are orbiting something else, which are in another gravitational field that haven't been sucked into ours. Our nearest galaxy is 2 million light years away. Then there'll be, there's a huge amount of galaxies out there. Scientists think perhaps 100 billion galaxies. So that's 100, that's 1 with 11 zeros after it. That's how many galaxies there are, and that's how we know where one ends and another begins. Jamie, thank you for your question. We can hear more about galaxies now, actually, and check in with the gang from Deep Space High, where Professor Pulsar and Sam are exploring Earth and finding out what radioactive dating is and how it can help us.
Deep Space High, Earthwatch, with support from the Royal Astronomical Society.
Jump into a wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
So the Earth was created about 4.5 billion years ago, right?
That's right.
And so was Mars.
Yep, Mars, Mercury, Venus, in fact, all the other planets in our solar system. Give or take a millennia.
And our sun.
Yes, Sam. Everything in the solar system was made around the same time. 4.5 billion years ago.
But what I don't get is how we know. I mean, humans weren't there. Nothing was there. It would have just been, well, a big swirling mass of dust, clumping into balls.
Sounds like the dust under your bed.
Hey, I cleaned my room last week.
All right, but haven't you learnt anything, Sam? There's an incredible amount we can tell just by observing stuff.
I still don't get it. Even if you observe, I don't know, all the oceans, mountains, volcanoes and clouds, where does it say 4.5 billion years old?
Well, the sort of dating you're talking about isn't done by looking at massive things like oceans and mountains. It's done by looking at some of the tiniest particles in the atoms of rocks. It's called radioactivity dating.
Sounds kind of complicated.
It is, but there's a simple way to explain it. Let's pop over to Greenland. It's nice and snowy there, and I fancy building a snowman.
Couldn't you find an example somewhere hot?
Pay attention. Now look here. We have 2 snowmen. Just using powers of observation, can you tell which is the oldest?
Well, one is still very round and tall. He's still got his hat on. The other one has started to melt a bit. Yep, I can see he's in a puddle of water. Obviously, the melted one is the oldest one.
And you can tell because of many things, like snowmen begin to fall apart as time goes on.
So, it's same inside rocks?
You got it. If you were to go inside the atoms of rocks with very powerful microscopes, you'd be able to see that tiny elements, particularly uranium, have also begun to break down. It's called radioactive decay. The amount of decay shows us how old the rock is.
OK, that tells us how old Earth is, but what about the rest of the solar system?
You're forgetting about all the meteorites, lumps of rock flying around the solar system. Plenty of them land on our planet, and we know that every one is the same age. All thanks to radioactivity dating.
I think I'd be more thankful for a big woolly jumper.
Fair enough. Let's get radioactive and get out of here.
Deep Space High, Earthwatch, with support from the Royal Astronomical Society. Find out more at funkidslive.com/deepspacehigh.
And that's it for this week's Fun Kids Science Midweekly. You can hear more from Deep Space High wherever you're listening to this. We've got tons of our science geniuses there too. It's also on Google, Apple, Spotify, on the free Fun Kids app and at funkidslive.com. You can send in your questions for another episode of our podcast. Record your voice note on that free Fun Kids app and on our website. And Fun Kids are our children's radio station from the UK. You can listen all around the country on the app, on the website. And if you've got a smart speaker, wake it up and ask it to play Fun Kids. And I'll see you soon.